Welcome to the Open BIM Live online seminar. In this presentation, you'll learn how Open BIM projects are shared among architects, engineers, builders, and clients. You'll see how Rift architects save time and money by implementing the Open BIM collaboration workflow to design and build a high-end residential complex in Norway. A live Open BIM workflow demonstration will also be presented using Graphisoft ArchiCAD, Tekla Structures, and DDS-CAD. Enjoy the show. First, let's take a look at why the question of open versus closed came into the picture in the first place. Building design, documentation, and construction were traditionally sequential processes. Due to changes in technology and the increased competition on the AEC market, the time allocated for projects significantly shrank, and as a result, processes became more and more parallel to comply with the increased demand. A few decades ago, projects were designed and delivered using blueprints. In these paper-based workflows, coordination between the different trades was a manual process, the light table being the only technology implemented. Computer-aided design, or CAD, didn't change much in this process. XREFs were only more efficient digital light tables, but the coordination workflow was still based on matching 2D lines and fills. Simple file compatibility between the different 2D applications was more than sufficient for such a coordination process. With the widespread use of building information modeling, or BIM, model-based coordination is expected to be the norm. The only issue is that coordinating intelligent BIM elements is a completely different story than coordinating 2D lines and fills. Now let's see why. BIM provides significant advantages for the AEC industry, yet it also raises some issues that were unknown in the conventional collaboration processes. For example, different project members working on the same building often require completely different types of data about the same building. For instance, columns for architects are typically interpreted as single longitudinal elements, even in multi-story buildings. Structural engineers, on the other hand, interpret columns as parts of the load-bearing scheme of the building. As a result, they need to split at each building story. The same applies to slabs. For example, while architects may only be interested in composite layers, structural engineers will need to know and model the details of the load-bearing elements. It should be clear by now why simply converting each other's BIM models won't help a lot in the coordination workflow. Another issue to be resolved concerns the various regional standards, conventions, languages, and applications developed by different vendors used by AEC professionals all over the world. There cannot be one single solution that addresses all the requirements for every professional in every region. The contrary is in fact true. The sole interest of the professionals is to use the best global or local BIM solution available for the given task or purpose in every project. As more and more AEC professionals implement BIM in their practice, there's a growing need for a reassuring solution to the previous issue. In 2010, McGraw-Hill Construction conducted research across Europe about BIM implementation. The number one request for improving BIM was to improve interoperability between the different software applications. The American Institute of Architects, or AIA, similarly declared support for open standards in 2009. Now let's see how these conceptual issues are being addressed through Open BIM workflows. As we saw, there are conceptual differences in what type of BIM model the different building professionals require. To provide the basis for necessary coordination between these BIM models, we need to implement the following three simple concepts. The first concept of Open BIM collaboration is the so-called reference model concept. In the Open BIM workflow, BIM models of the different trades are not open for editing by the receiving party, only referenced for coordination. This also mirrors the real-world setup where parties carry full responsibility for their part of the project. Hence, they also require full ownership of their BIM data. The first benefit is clear ownership of models. Everyone can maintain full control over their part of the BIM model. The second benefit is that the focus is on workflow compatibility. As a result, it's easier for professionals to participate regardless of their BIM software. The third benefit is that change management is much more easily provided due to workflow-level compatibility between the different parties. The second concept of Open BIM collaboration is based upon model filtering and classification. The BIM model being shared with other disciplines should always meet the requirements of the receiving party. For instance, the structural or MEP engineer may not need the entire architectural model for their work, only relevant elements and information. Here, model filtering ensures that only relevant elements are sent to the other party, while model classification ensures that the information sent will be perfectly interpreted by the recipient. The third concept of Open BIM collaboration is the active support of change management. Real collaboration workflow is bidirectional and dynamic, meaning there are continuous round-trip iterations. To fulfill this requirement, Open BIM collaboration offers workflow-level support for change management, where existing, new, modified, and deleted elements are intelligently handled, and the updates are clean and lean in terms of the information inside, the size of the data package sent, and the way the receiving party handles these changes. As you can see, the open collaboration workflow is based on a handful of simple principles that can be applied virtually between any two BIM solutions. Let's now summarize the 5 main requirements of the open workflow. System independence. The open collaboration workflow must work regardless of the actual software application being used. Workflow transparency. The collaboration workflow should be clear to all members, regardless if they were members of the project from the start or are just joining. Ownership of the BIM data. Just as in real life, different trades need to be able to take responsibility for their part of the BIM model. Information classification. It's necessary for the information to be provided in a way that is easily interpreted by the receiving party. Reference model concept needs to be applied to ensure the above requirements are easily being met. As a result, the Open BIM workflow turns technology into a solution. It's important to note that Open BIM is more than IFC. While IFC as an open standard is a mission-critical component to Open BIM, an active engagement between the different stakeholders and participants in open collaboration is also required. Open BIM per se can only be an inclusive system, providing accessibility to any participant in the project who wants to sign up. Before starting the live Open BIM workflow demonstration, let's take a look at how the architects designed and built this residential complex. The Nordre Jarlsberg Brigade high-end residential complex was designed by Christer Wanvik of Rift Architects in Oslo, Norway. Located in the heart of the Oslo Fjord, only 40 minutes from the capital city of Norway, this high-end residential complex consists of multiple parts. The first complex, consisting of 85 flats, has already been completed, and the residents have moved in. Rift Studio is a creative and dynamic architectural studio that knows that using the latest technology saves time and money. The firm implemented the BIM workflow with the help of ArchiCAD in 2008 as a way to create and document architectural design at a professional level. Let's take a look at how they used the BIM model on the Brigade project. One of the great advantages of working with ArchiCAD and Tekla together was that the architects, engineers, and construction engineers were able to discuss the project in 3D instead of 2D paper drawings. This enabled them to avoid problems in the construction phase by giving them the opportunity to work everything out prior to the beginning of the construction process. In addition, using the IFC model and the ArchiCAD model was a very efficient way of working, not to mention the fact that the architects and builders are much more confident about the results. Another important use of the 3D model was when it came time for sales. Early on, they could study which apartments would have nice views of the fjord and which were perhaps less desirable. They also used ArchiCAD Sun Studies to learn more about the insulation of the different apartments. This made pricing the units easier for the real estate broker. They also made a BIMX project file, which is available from the sales firm free of charge for every potential customer. Future customers can now perform virtual fly-throughs of their potential apartment and see the colors in the view without installing, buying, or learning new software. All in all, the 3D model with the IFC technology provided full control for Rift Studio in the design and construction of complex projects. Graphisoft ArchiCAD is a unique building information modeling, or BIM, solution built by architects for architects. Implementing BIM in your everyday design practice means that you'll need less time to complete and deliver an architectural project. Also, the design, coordination, and collaboration processes will be smoother, shorter, and more productive. ArchiCAD is the most widely localized BIM solution for architects worldwide. This means that it's not only translated into 17 languages, but is actually available fully localized to 25 national standards in more than 100 countries. In addition, ArchiCAD is the only true BIM application running on both the Apple Macintosh and the Microsoft Windows operating systems. Now let's see the OpenBIM workflow in action, starting with Graphisoft ArchiCAD. Here you can see a 3D view of the entire architectural project in ArchiCAD. We can use the full model for data exchange with other applications, but this live presentation will be done for one building part of this residential project. The first concept of OpenBIM collaboration is the so-called reference model concept. The architectural design must be shared in a way that meets the requirements of the receiving party. In our case, it's the structural engineers using Tekla structures. In other words, we want to export only those load-bearing elements that are necessary for structural engineers. The second concept of OpenBIM collaboration is based upon model filtering and classification. In order to perform a quick and fully automatic element filtering, it's important that all the elements in the architectural model have the appropriate element and load-bearing function classifications. Let's select this slab, for example, and open its settings dialog. Here we see that we can set the function classification of this particular slab element as load-bearing or non-load-bearing, depending on its actual role in the design. The classification settings of the elements have a direct effect on the content of the exported IFC file. The load-bearing properties of the elements represent a standard IFC property, which are interpreted accordingly by all IFC-certified applications. Another important aspect of the element classification is the element type. For instance, this slab was created by the Slab tool of ArchiCAD, so its default element type classification is set to slab, which is also a native IFC element property. At the same time, the element type classification could also be set to ceiling if we were to use this to model the suspended ceilings in our project. Finally, we can set the position of the actual element compared to the building envelope. For example, this slab can be classified as an internal or an external element. Any custom properties can also be created, if required by the engineers or consultants who will work on the exported file. For instance, acoustic and fire ratings, and so on, can also be set for every individual element as standard or custom IFC properties. To prepare the model for structural export, element classification plays a crucially important role. When using steel elements, it may be important to use standard steel profiles. This greatly helps the work of the structural engineers. Standard steel profiles are automatically recognized and identified by Tekla structures. ArchiCAD has a built-in steel profile catalog, which contains thousands of standard steel profiles grouped by country codes and shapes. We can easily make these profiles available for the project beams and columns. For example, the profile of this steel column was set to rectangular hollow section. Now let's activate the partial structural display option of ArchiCAD. This feature helps us to display only the elements having been classified as having a load-bearing function. This means that in cases of composite structural elements, only their core load-bearing element will be displayed. The window and door elements can also be hidden, and only their nominal opening will be displayed, since typically structural engineers require this. Let's summarize. All elements in the architectural project model must be appropriately classified. This enables us to filter the architectural model and display only those elements that are necessary for the receiving party. In our case, only the structural load-bearing elements are displayed. And now we will export this for the structural engineers in IFC file format. All we need to do is use the Save As command in the File menu. Then select the IFC file type from the list. ArchiCAD supports all versions of the IFC 2x3 format. Let's select the IFC zip file format. This will produce a compressed IFC file that can be easily sent by email to the engineers. We can choose the most appropriate IFC translator from the default list of translators. Custom translators can also be created according to the requirements of the receiving party. Let's select the Tekla Structures IFC translator for now. Let's briefly review the settings of the selected translator. Here you can see that the content of the exported IFC file can be carefully fine-tuned to export only the necessary elements from the architectural project model. In this case, only the structural elements of the architectural model will be exported, since these are the elements that are necessary for the work of the structural engineers. We can also decide if we wish to export the entire project or only the visible or selected elements. Let's save the visible elements only now, the load-bearing elements seen in the current 3D view, and let's send it to the structural engineers using Tekla Structures. Tekla is part of the Trimble group of companies and is a leading international BIM software supplier, providing solutions for all construction team members. Tekla has its own offices in 15 countries, a network of over 30 resellers and partners, and 35 localized environments, providing global expertise in the construction industry with customers in over 100 countries. Tekla Structures is a BIM solution that is focused on the construction supply chain, turning architects' designs into reality. The unique ability to handle the amounts of detailed information required for a construction project in one BIM model further supports the workflow from architect to engineers to manufacturing and construction. Here you can see the imported architectural IFC project model imported as a reference file to Tekla Structures. We can track any changes that the architect may make to the reference model by using the change management functionality in Tekla Structures. Let's have a quick look at the properties of this window, for example. All this information is taken from the architectural IFC project file. Such detailed object-level information allows constructors to create a very detailed breakdown of all building components for fast and accurate quantity takeoffs. Tekla's Model Organizer functionality displays all elements of the project. Here, for instance, you can see a detailed breakdown of the architectural building components, such as balconies, columns, external walls, and so on. Here you can see an isolated part of the model. We'll create the structural design for this part. As soon as we select the architectural element called balconies in the Model Organizer dialog, they'll be immediately selected and highlighted in the 3D project view as well. Initial quantity takeoffs and lists can then also be generated instantly. Let's have a closer look at the load-bearing elements exported from Graphisoft ArchiCAD. For example, here you can see the detailed properties of a structural column. Structural engineers don't need to recreate these elements. Instead, we can use the Convert IFC Object function provided by Tekla Structures. This allows us to take over the basic properties of the structural element created by the architects. There's no need to recreate these elements from scratch, which saves a considerable amount of time. This also hands over the responsibility of the structural elements to the engineer, therefore supporting the BIM workflow. All we need to do is select the element we wish to convert, a column and a slab in this case, and then activate the Convert IFC Element command in Tekla Structures. A report on the results of the conversion process and the structural profiles applied is automatically generated and displayed. We can continue the conversion for all the elements provided by the architect and create the structural model in seconds, ready for the structural design. Here you can see, for instance, how the architectural monolithic slab is converted to hollow core reinforced concrete planks used by the structural engineer. The rest of the architectural elements are also converted to their corresponding structural equivalents, as you can see on the screen. The structural engineer can now start the work by creating the analysis and design model. Let's consider some of the structural elements, such as a column and two beams. The analysis model is then created from the converted parts in seconds. Here you can see the created analyses and design elements in a 3D wireframe representation mode. The analyses properties of the structural elements can be manually adjusted if necessary. For instance, here we can adjust the axis of the selected beams manually. Once the analyses model is ready, it can be taken over to any chosen analyses application with the help of the IFC protocol. After carrying out the analyses, we can add more structural members to the model. For instance, we can insert the appropriate foundation as soon as we know the foundation loads. We can also add structural details to the model using the rich component catalog provided by Tekla Structures. Let's choose pile cap reinforcement from the catalog and apply it to the selected column foundation. The result can be displayed instantly. All we need to do is change the transparency of the 3D model view to display the previously inserted pile cap reinforcement bars on the screen. Further structural connections between the steel columns and beams can also be inserted. In this case, we'll insert a shear plate connection between these steel elements. The result is instantly displayed on the screen. Let's continue and create the general arrangement drawings for the structural design. This drawing is generated automatically from the model in seconds. Any changes performed by the structural engineers will be automatically reflected in the GA drawings as well. The very same applies to the assembly drawings of the steel elements or the cast unit drawings of the concrete elements. Various reports can also be produced at any stage of the structural design using the required level of details. Let's create a simple engineering report for now. All we need to do is select the elements we wish to include, and the report will be generated instantly. Such reports can provide accurate feedback about quantity takeoff or help material ordering as well. We can also have a look at the task manager of Tekla Structures. This enables us to integrate the project schedule with the elements that we're working on. Let's take a ground floor slab, for instance, and add this to the foundation slab task. You can see that the schedule is automatically updated based on the plan production we're working on. This greatly helps constructors to start planning the construction sequence very early in a particular project. Task Manager can also use the elements created by the architects and brought in earlier from Graphisoft ArchiCAD. Once the structural design has reached a certain stage, we can transfer the created model back to the architects. We can do that either by using Tekla BIM site, or we can also export the model as an IFC file and send it back to ArchiCAD. In ArchiCAD, we could decide to open an IFC file as a new standalone project, or we can merge the IFC model or a part of it to an existing project. We'll perform the latter. All we need to do is activate the merge command and select the IFC file sent by the structural engineer. Let's use a proper IFC translator. Now we select the Tekla Structures IFC translator. The merged information will be placed on a layer system set at the import options. Now we keep the original layer names of the imported IFC file and add the Tekla extension to them. The material conversion table can be used to handle the conversion of the material used by the architects and by the engineers. ArchiCAD provides a complete solution for the ownership of the models. The work of the structural engineer can be easily distinguished at any time and in any view of the project. The structural model can be displayed as a protected reference model or as an editable part of the project in views: 3D window, floor plan, section, and elevation views. Thanks to layer system settings, now all the architectural elements will be displayed in wireframe representation mode, and the elements created by Tekla Structures are displayed by solid colors. Let's zoom into some details of the referenced structural model. Now we can see the detailed concrete hollow core slabs, steel columns with hollow sections, and so on. All the fine details are successfully imported and correctly positioned by ArchiCAD. We can query the properties of the elements that arrived from the structural model. For example, selecting this balcony slab, we can check the properties set by the structural engineer, such as the material, profile, and other IFC properties. If the structural model contains steel connections including bolts or reinforcement bars and meshes, we can, of course, display them together with the building elements as part of the reference model. The merged structural model can also be displayed on the floor plan or in sections as well. Let's open a section view of the architectural model. With ArchiCAD's Trace and Reference tool, we can overlay the architectural element with the structural elements, for example in red. With the help of the slider, we can visually identify any inconsistencies between the two models. Let's proceed now and see how the OpenBIM workflow performs with mechanical engineers. We'll start the collaboration process in the very same manner as before. This time we will export the architectural model for the mechanical engineers together with the zones, since the zones function play an important role in the MEP calculations. Let's export the IFC file using the dedicated DDS-CAD MEP translator this time. We'll send the exported IFC file for the MEP engineer using DDS-CAD. Data Design System is a Norwegian company founded in 1984. Located in Stavanger, DDS is a publicly traded company on the Norwegian Stock Exchange. Since 1984, Data Design System has been developing their flagship product, DDS-CAD, in-house. DDS-CAD is a standalone system and is available in many configurations that can be tailored to meet both your current and future requirements. DDS-CAD is an expert system for MEP engineers, where the functionality supports business processes in the way MEP engineers would approach them in a BIM paradigm. Thanks to the use of intelligent objects, DDS-CAD offers its end users a variety of integrated calculations that allow them to optimize the designs they create. Open standards are used to exchange models and other information between design tools. Currently, more than 15,000 users worldwide use DDS-CAD in their daily design routines and are producing highly detailed multidisciplinary BIM models together with their design partners. Let's switch to DDS-CAD now for a live demonstration. First, we're going to import the ArchiCAD IFC model. Via the menu Insert, we can select the IFC file from our Windows directory. In this dialog, we can select the import options for the IFC model. For this project, we're going to import the IFC model and convert it to DDS objects. This allows us to further process the project and reuse or enrich existing data, for example, for technical calculations. Once the ArchiCAD model has been imported, we can see the floor plan and all objects that have been converted to DDS objects. The complete ArchiCAD IFC model can also be viewed in render mode. Thanks to the information in the ArchiCAD IFC model, DDS-CAD recognizes external and internal walls, windows, doors, and other objects. Furthermore, a complete room list is directly available. The room list can be accessed either in the model itself or exported in a report template. On the left side, we see the room numbers, description, and its surface-selected rooms are highlighted in the model. The report template lists all room information, including the surface and volume of the entire building. The existing building model allows us to directly start planning building services like electrical installations. 2D symbols can be inserted and positioned accordingly. In this example, I'll insert a flush-mounted double light switch. All 2D symbols have a 3D representation, as can be seen when we activate the camera view. The ArchiCAD IFC building model also directly allows us to do light calculations. DDS-CAD has an integrated light calculation. However, the software also offers the possibility to make use of even more advanced light calculations. For this, a bidirectional interface with Dilux and Relux is available. In this example, we'll use the Dilux conversion utility. The interface allows us to export all rooms directly into Dilux. Once we open Dilux, we see that the room geometry and other important objects like windows and doors are imported as well. For this webinar, we have already inserted a few light fixtures and did a light calculation in Dilux. This information can again be directly imported into DDS-CAD either for single or for multiple rooms. By opening the STF file again, all light fixtures can be inserted in DDS-CAD and will be positioned and rotated automatically in the building model. Furthermore, ISO lines display the LUX information. This is a good example of how information from the ArchiCAD model is reused by DDS-CAD, passed on to Dilux to enrich it, and is again transferred backwards into the DDS-CAD BIM model. As you've noticed, the ArchiCAD IFC contains valuable information for DDS-CAD. Thanks to the import option of mapping the IFC file to DDS objects, we're also able to do technical calculations, for example, a heat load calculation. The heat load calculation is accessed via the Building Information dialog. With a single click, we can exactly define the heating requirements on a room level within the complete building. The information can be displayed directly as room text. Furthermore, an extensive report according to the EN 12831 standard is available. This report combines the information from the ArchiCAD IFC enriched with the calculation data from DDS-CAD. Based on the heat load calculation, DDS-CAD can automatically dimension and position radiators within the building model. We've prepared a system for which we've had DDS-CAD automatically define and insert the radiators, and we've designed the main routes for the pipe system. Objects like radiators, sinks, and toilets can be automatically connected by using intelligent connection functions. DDS-CAD offers the user various possibilities depending on the situation at hand and the selected object. With a single click, DDS-CAD automatically connects the selected radiators to the pipe network. This can be clearly seen in the render mode. This function also exists for air terminals and other components related to ventilation and air conditioning. In DDS-CAD, you do not, per definition, have to take into account the size of components that you use to connect your objects with, and in the end form a complete system, while DDS-CAD offers you integrated calculations that automatically dimension systems according to defined parameters. In this example, I will first connect the two remaining air terminals to the existing supply system, and have DDS-CAD calculate the ventilation system for supply air. In the Building Information dialog, I can select the system I'd like to calculate. To open the Calculation dialog, I press Start and select the Calculation tab. Within the Calculation dialogs, I have various options available that can influence the calculation. For example, I can fix the size of certain branches, choose to have DDS-CAD insert reducers, or define a maximum air velocity. Once I've run the calculation, DDS-CAD automatically updates all components and inserts reducers if required. Furthermore, all information is available to be automatically shown in the model. When I label a specific part of the duct system, I not only have size information available, but also flow rates and velocity. Last but not least, DDS-CAD offers an extensive bill of quantity, which is directly available either for a single discipline like ventilation, or all disciplines when they're all activated. The bill of quantity can be exported again for further processing. Thanks to the use of intelligent information exchange via open standards and intuitive functions and integrated calculations, DDS-CAD allows you to completely optimize your installations and work more efficiently. Once you're finished modeling, you can export your complete system as seen in render mode, or each discipline separately to IFC again via the Export IFC function. Enter a file name for the IFC export. The Export dialog offers various export options depending on the purpose of the export file for IFC. The exported IFC model can be re-imported again, for example in ArchiCAD or BIM site, for further coordination and quantity takeoffs. The merging process is the same as shown before for importing the Tekla Structures model. We use the merge command with the dedicated DDS-CAD MEP translator. We've received IFC files from the MEP engineers, a model of the ventilation system and a model of the sanitary and heating systems. Now, let's see first the merging result of the ventilation system. This 3D window displays the architectural elements in wireframe mode, while displaying all the MEP elements received from the engineers with solid colors. Let's zoom in on some details of the MEP system model. Thanks to the dedicated translator and Graphisoft MEP Modeler add-on used for the import process, the ventilation ducts became native duct elements in ArchiCAD. The properties set by the mechanical engineer can be checked by instances with their settings dialog, or can be checked for the entire model by the IFC manager. Here we can see the custom properties, which are the data calculated and exported by DDS-CAD MEP. Let's see some details of the sanitary and heating system. Now we can see some detailed pipe elements, then some heating parts, and a closer view of a heater element. The merged MEP model, similarly to the imported structural model, can also be displayed on the floor plan or in sections as well. Let's use the Trace and Reference tool again to show both the architectural and ventilation elements together in the same section view. The ventilation elements are displayed in blue now. A real collaboration workflow is bidirectional and dynamic, meaning there are continuous round-trip iterations. To fulfill this requirement, open collaboration requires workflow-level support for change management, where existing, new, modified, and deleted elements are intelligently handled. For example, in ArchiCAD, we can compare two versions of the same IFC model and merge only the changes into the project for later checking. The markup tool collects the detected changes grouped in different statuses and in different colors. The geometric and position changes are displayed as modified elements in pairs. The new and deleted elements are also highlighted with different colors. As you can see in this example, the solar shading system of this balcony part has been modified, reduced. 2 columns were deleted, 1 new column was added, and the roof size was modified by the structural engineer. Then we can accept or reject the changes suggested by, for example, the structural engineer in the architectural and/or referenced model environment. Let's see how constructors, consultants, owners, and clients can also join OpenBIM. Tekla BIM Site is a professional tool for model-based project collaboration that includes all the information necessary to manage a construction project, from design to construction and site management. All disciplines of the construction workflow can combine their models, check for clashes, add comments, link documents, redline, and share information using the same easy-to-access 3D environment. Tekla BIM Site is available in a free internet download. Graphisoft BIMX is an innovative interactive BIM communication tool for designers, setting new standards for design communication and presentation. BIMX allows architects to explore their project designs in a 3D environment using familiar navigation techniques in a professionally rendered navigation environment. The intelligent BIM model incorporated into each BIMX project shows all types of BIM element information and accurate measurements. Experience the masses and spaces of the design project, feel the relationship between the different volumes and rooms, and understand the architectural design concept and design ideas in a new and distinctive way. Share your design project with virtually anyone without having to install any application or software. The standalone interactive 3D presentation package is available at any stage of the design as a single executive file on both Windows and Macintosh platforms, iPads, and iPhones. It can also be shared on the BIMX community portal. We've seen the OpenBIM workflow in action. Now let's see how the OpenBIM program facilitates globally coordinated promotion of the OpenBIM concept throughout the AEC industry. The OpenBIM program has 3 important components. Number 1, unified communication. OpenBIM is a popular subject throughout the AEC industry. We have to recognize, though, that it can only begin to make an impact if everyone talking about Open BIM understands it to be the same thing. To help with this, the Open BIM program offers a clear, high-level Open BIM definition all program participants accept and promote in a unified way. Number 2, unified branding. Unified communication is much more powerful if the references are identifiable. In order to help easier recognition of communications in the framework of the Open BIM program, we offer a unified Open BIM branding for program participants. Number 3, full AEC spectrum. We must also realize that Open BIM can only be successful if it's implemented by the full AEC spectrum, including AEC practices and projects, in addition to software vendors. In order to facilitate this, the Open BIM program sets clear requirements for the different various stakeholders of the AEC industry. The benefits of Open BIM are numerous, but all participants will definitely benefit from working with the best-of-breed software solutions in their respective fields, maintaining full control over software upgrades independently from others, greatly reduced coordination errors due to workflow-level compatibility, and BIM projects delivered with Open BIM workflows will result in BIM models that are much easier to use throughout the entire life cycle of the building. We've reached the end of today's presentation. We hope that you found it useful and will join us for future events as well. Thank you very much for taking the time to watch.